Hi everyone, welcome back to our channel. Today we will be creating a topology and mesh on a nacelle with a spinner. Note that the nacelle has a flat bottom, which is different from the conventional circular nacelles. The flat plane located below the nacelle represents the ground surface, and its close proximity to the nacelle is used to study the ground effect phenomenon. 2D topology. We start by taking the sectional view through the middle of the geometry. Then, we create a simple 2D topology addressing only the nacelle and the spinner. Make sure to create the corners a little away from the surface, as this ensures that the corners remain outside the surface upon revolution. Before revolving this topology, however, we need to perform some additional wraps which ensure that we generate a good grid. First, group the following corners and do a boundary wrap. Next, we group the corners closest to the inner plane, the plane inside the nacelle, and perform another boundary wrap. We now select all the corners closest to the nacelle and wrap it. This creates a H-type topology at the intersection of different surfaces, spinner and inner plane and nacelle, which ensures orthogonal cell placement at the concave surface intersections. We assign all the corners in the 2D topology created to their respective surfaces. Revolving the topology. We will now revolve the 2D topology about a given center and axis to create the 3D blocking for the nacelle and spinner. The circular with core option can be used to automatically create blocking inside the core region of the revolved topology. We shall rotate the 2D topology about the center of the spinner, which is at 0, minus 185, 0. The topology is rotated about the y-axis. We shall create only 8 copies of the 2D topology upon revolution. This makes it easier to copy the block faces to the outer domain. Add the corners to create the core blocking in a corner group and provide that as the input in the revolve tool. On clicking apply, we can see that the topology has been rotated and blocking has also been created inside the core. Extending the topology. We can now work on extending the topology to address the outer domain of the grid. Group only the outermost corners of the revolved topology in a corner group. To create blocks in different directions, we group the faces which have their normals in the desired direction of the bounding planes and copy it to the locations close to the planes. The to-surface option under copy can be used to copy the block faces with links to the current surface. Before copying the wireframe to the plane located upstream of the nacelle, the inlet, we need to group all the faces which are located in front of the nacelle, including the faces created as part of the core topology. This is then copied to the inlet. Clicking on validity shows us that we have a valid topology. Before generating the grid, however, let us change the density of the block edges according to their lengths. The preview option can be used to look at the approximate cell sizes while adjusting the density. We can now run grid for a couple of hundred sweeps, which gives us a good grid with a low maximum skew of around 0.76. We can also see how the orthogonal cells have been created at the surface intersections. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. If you have any questions or any comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Follow us on our social media pages. Links are posted in the description.